Hey guys, welcome to my YouTube channel. So in this lecture, we are going to continue our discussion on the digital electronics. So in the first topic that we are going to start is the number system. So as you guys know, so there is no number system means we guys may know only binary systems is present in digital electronics. Not like that. There is plenty of things is there. So one of the first starting is the radix-r. So radix-r. So I will let you know what does mean by radix-r. Everything I will let you know. So another one is the BCD codes. BCD codes. So this is some different thing. Then data representation is another one thing that we have newly added in every syllabuses. So data representation and then fixed and floating point. So this is also a new thing added there. Fixed and floating points. So we will be detailedly discussing all this. So once this is done, number system is done. So floating and fixed points. So in the radix-r, what are the different terms comes under is the binary, octet, decimal, and hexa. So these are four different. There is many thing. Even you can name one of the radix-r number system, but this is the four thing only. It's fundamentally available in the syllabus or is a IEEE standard one. So BCD thing is the weighted and unweighted. So like that only they will categorize this one. So which is weighted and unweighted. We have two different things there. So rest two things also the same. So weighted, unweighted. Okay. And then data representation, fixed point also we will cover. So these are some four subtopics. So we will cover detailedly everything. Okay. So let's start with the radix-r distributions, radix-r number system. So what the base or radix? Even radix is also called sometime as a base. So base or radix. So base or radix of number system is nothing but number of different symbols present. So base and radix of number system or the particular any number of particular system you can take decimal or a binary anything. So number system is number of different symbols. So it's nothing but number of different symbols available in the particular base. Number of different symbols in a number system, particular number system, anything maybe decimal or binary, octave or hexadecimal, anything in the particular number system. For an example, if you have a base r, base is equal to r, then there will be r different symbols. So r is the character, r different symbols will be there. So r is a algebraic expression. So r different symbols. So the range will be from 0 to r minus 1. So range will be from 0 to r minus 1 unique characters or different symbols. So any numbers can be represented with these r symbols by multiplying with its position. So that is how we will be doing. So that thing we will detailedly cover in this lecture itself. So let's have a radix. So radix r and symbols. How many number of symbols? Let's go through the four things we have. So first one is 2 binary. So we everyone know, even a child know that is a computer will know only 0 and 1 like that way. So let's take 8 octet. So it's from 0 to 7. So 0, 1, 2, 3, 4, 5, 6 up to 7. Then decimal, we the normal mathematics which work with this. So 10 decimal, so which is from 0, 1, 2, 3 up to 9. Okay. So then 16 hexadecimal. So this we guys know, right? IPv6 everything this is only there. So this is will be next generations will be ruled by these numbers only. So this is from 0, 1, 2, 3 up to 9. Then A, B, C, D, E up to F. So F will be 15. From 0 to 15 it will be. From including 0 there will be 16 different symbols will be there. So how this can be represented is what the trick. So any number maybe x3, x2, x1 and x0 dot decimal or point, y1, y2, y3, it may go to anything. This we can represent this as a base. So this R is the thing that will indicate this base system. Then what is the max and different number of symbols present is identified by this base R. So how this can be written in normal expression or any kind of conversion or any expression is a dot 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 x3 into R3 plus x2 multiplied with R2 plus x1 R1 plus x0 R0. I have skipped this multiplication. This will come here. Okay, so this one. Then plus the decimal terms will be written as y1 r power minus 1 plus y2 r power minus 2 plus y3 r power minus 3. Then it will go. So this is how we will be representing any kind of base radix number in the expressed way. Okay, I hope it's understood for you guys. So let's then start the conversion part. So if we know how to convert from one thing to another thing, then these kind of things we will be covering very sooner. So let's see how the conversion from one base system to another base system will take place. So let's take the very basic thing, decimal to anything and anything to decimal. So because in the current thing we use only decimal, right? So let's take two things, decimal to anything, then anything to decimal. So this will, if you first start with this, then it will be understood for you guys. So that's why starting with this one. So decimal to any. Okay. To convert a decimal number to any base, any other base, divide the integer part repeatedly. Divide the integer part repeatedly with the required base. Which base we are going to convert? If we have to convert, then we have to repeatedly multiply with the required base. And multiply the fractional part repeatedly with required base. And multiply. We have to multiply the fractional part. Okay, integer part we have to divide it. Multiply the fractional part. If you guys see the example, it will be clear. So for now, let's bear with the theoretical explanation. Repeatedly with the required base. So with base, I'm mentioning at base. Okay. So if anything to base, so second thing is the any to decimal, any base to decimal. This will be quite easier, just a simple multiplication of 10 power thing. Okay. So to convert any base to decimal, multiply each digit with required base. So multiply each digit with the required base. Okay, I hope it's understood. So let's take an example. Okay. So first example, let's start with the 37.3125. This is in a base 10. This is in decimal format. What will be the conversion to binary? Okay. So let's take the integer part separately, fractional part separately. The integer part need to be repeatedly divided by the required base. The required base is this one. So 2. So if it is divided by 2, then 1, 1, then it will be 8. Remaining will be 1. Then 2, then 9. Remaining will be 0. It's normal LCM thing, right? So that way. 4. Remaining will be 1. Then 2. Remaining will be 0. Then 2. Then remaining will be 1 and 0. Then again if we divide by 2, then remaining will be 0 and 1. We have to make sure until it's get into the thing. Okay, 0 until 0 comes here too. So now let's split this one, and if we write from this to this, okay, this is where we have to write it. Okay, so it will be 1. This is 0, right? We can skip it. From here we can write it So 1 0 0 1 0 1. Okay, so this is what the base part which is in binary. So this fractional part we have to multiply it. So 0.312 0.3125 into record base. So it will be equal to 0.6250 625, right? So 625. Then this part, this decimal part, 625 into 2. Okay, so if you write it, then it will be 1.25. Then this fractional part, 0.25 into 2, then this will be 0.5. Then this 0.5 into 2, then this will be 1. So until we get 1, we have to write it. So now we have to write this way from only the integer parts. So if we write it, then it will be 0.0101, which is 2. So if we combine both things, then 37.3125 base decimal, which will be equal to 100.101.0101 with the base 2. So this is how the conversion. The lengthier number here in the base radix 2, which is equal to the shortest number which is represented in the radix 10. So I hope this is understood for you guys. So even try another more scenarios and then do it. So take a homework of this sum. Try and post in the comment section that what will be this is 37 the same thing, 37.125 with the base 10 decimal index. What will be the exact version in 8? So let's take octet. So the record base here will be 8. So instead of dividing continuously by 2, divide by 8. Instead of multiplying by 2, here multiply by 8. And then please post the correct answer in the comment section. So then we will compare. Tomorrow I will solve this session and we can compare the results how it is coming. So like, share and subscribe. Stay tuned for the next lectures.